Saturn has been found to have a core like jelly or sludge that is potent enough to cause ripples across Saturn's rings. The astonishing findings contrast what astronomers previously thought about the planet. Instead of a hot ball of rock in the center of the gas giant, there is a diffuse, fuzzy amalgamation of ice, rock, and metallic fluids. We use Saturn's rings like a giant seismograph to measure oscillations inside the planet, says Jim Fuller. The diffuse core of the Saturn revealed by the ring seismology published in Nature Astronomy. This is the first time we have been able to seismically probe the structure of the gas giant planet, and the results were pretty surprising, although the notion of using Saturn's oscillation as a makeshift seismograph to study its interior was first raised in 1990s, says Jim Fuller. The gravitational ripples make the planet's surface move approximately 1 meter every 2 hours, like a rippling lake, with rings around the Saturn picking up the disturbance and moving themselves. While the interior of the Saturn is sloshing around as a whole, it is made up of many stable layers with heavier material sinking to the middle of the planet and lighter material floating on the top. For the planet's gravitational field to be oscillating with these particular frequencies, the interior must be stable, and that's only possible if the fraction of ice and rock gradually increases as you go in towards the planet's center. The hydrogen and helium gas in the planet's center is akin to Earth's ocean, but the ratio of the salt in comparison to water increases by the depth. These results indicate that the core of the Saturn is 55 times greater than that of the entire Earth, with only 17 times mass of our planet being solely ice and rock. It is also possible that Jupiter, the other gas giant in our solar system, has a similar core and raises further questions about the formation of such bodies. Current models about the formation of the gas giant suggest that the rocky cores form first and then attract large envelope of gas. However, if the planet cores are sludge like suggested, gas might be a much earlier component of the formation process. So what do you think? Does this mean all the gas planets in our solar system will have the same jelly wiggly core?